Wonderful. Thanks, Brian. Hello, everybody. My name is Fergus Kirkpatrick, and I am the Astro Pi Program Manager. So I'm based at the Raspberry Pi Foundation. And today I'm going to be talking to you about how to get ready for a live lesson that we're going to be running for one of the Astro Pi activities called Mission Zero. The live lesson is going to be at 2 o'clock on Thursday, the 13th of November. Apologies that my my video has gone a little bit blurry. Hopefully it will right itself at some point if I jiggle around a little bit. But I'm going to dive straight into Astro Pi and then tell you how you can join the session on Thursday and how to prepare for it as a teacher joining with lots of students. So first and foremost, the Astro Pi Challenge, the European Astro Pi Challenge. So what is the Astro Pi Challenge? Well, it is a collaboration between the Raspberry Pi Foundation and the European Space Agency that offers young people the chance to write a short computer program that will be sent to run on the International Space Station. What we're going to do today is I'm just going to introduce you to Astro Pi. I think I've covered this already, haven't I? But yeah, the three things to focus on are what is Mission Zero, which is the activity we're going to run on Thursday, what you need to do to register to get ready for it, and what to expect on Thursday as well. And hopefully at the end, we'll have some time for questions. So Astro Pi. An Astro Pi, what is an Astro Pi? What's Astro Pi mean? An Astro Pi is a Raspberry Pi 4 computer, which has something called a sense hat attached to it. And it's encased in this very hard casing, specially designed for it. And it has a camera attached as well. And there are two of these on the Columbus module of the International Space Station, which is the module managed by the European Space Agency. There's two Astro Pis because they have slightly different cameras. One of them has a visible light camera and the other one has a near infrared camera. And what you can find on them is that with the sense hat, if you're familiar with this piece of hardware, there's lots of different sensors that you can use. And there's also a 8x8 LED display, which you can see on the Astro Pi image on the left there. So the sensors that you can find, there's a temperature sensor, a movement sensor or PIR sensor, humidity, magnetometer, luminosity and color sensor, which we'll use for the Mission Zero activity. And there's also an accelerometer as well. And I'm just going to show you where you can find them. So what happens with Astro Pi, the computers, they live on the Columbus module. And then when we go into what we call deployment phase, which is when the programs actually run, they're positioned in one of the windows on the International Space Station. And this year, we're going to be positioned in the World Observation Research Facility, or WARF for short. And this is very good news because it's a very big window on the space station, meaning that you can get a full field of view when using the camera. So Astro Pi has been running every year, every academic year since 2015. And on the right there, you can see a picture of Tim Peake holding one of the Mark I Astro Pi computers, which he took on a UK Space Agency mission called Principia in 2015. And ever since then, we've been sending young people's code up to run on these computers. In 2016, it became a challenge run in collaboration with the European Space Agency. And ever since then, we have been sending the programs up. And since we started, over 160,000 young people have written computer programs and had them sent up into space. And each of those young people have received a certificate with the exact time and date that their computer program ran. So what do we do with these computers? So we have two missions that we offer, or different activities, if you will. The first one is called Mission Zero, which we're going to be focused on today. And the task or activity for Mission Zero is to write a personalized pixel art image, a program that creates a personalized pixel art image, which is going to display on the LED display of the Astro Pi computers. And it's also going to use a color sensor as well. Mission Zero is a fantastic introduction to Python programming. It uses a couple of key concepts, and it can be delivered within 1 to 2 hours, depending how much build-up you do around the core activity itself. On Thursday, we're going to be running it within an hour. So we'll be working towards kind of the more basic end of the spectrum, but it has a bit of stretch activity as well. And this is squarely aimed at young people, kind of 9+, depending on their kind of coding journey and how competent they are. The other challenge that we have is called Astro Pi Mission Space Lab. This is a bit more advanced, so we'd be thinking 12, 13+. And this is a longer project to be done as a team. And the task for this is to use the Astro Pi sensors, and you can choose which ones, including the cameras, to take data readings and use that data to calculate the speed that the ISS is traveling in kilometers per second. So this is aimed at young people who have some programming experience with Python or other text-based programming languages, and is a bit more on the advanced end of the spectrum. So on Thursday, we're going to be running Mission Zero as a live lesson. And as I briefly mentioned, the task for this is to create a piece of pixel art using Python code. It has a broad sort of nature theme, and we say on Earth or beyond, because in reality, lots of people send us pictures of aliens and rockets and all kinds of other wonderful things that they've created. So it's a fairly broad church, if you will. But it has to be inspired by nature of some kind. And the program that we're going to write and that we have a guide for, they are going to follow some steps in a step-by-step guide to help them create a program which produces a pixel art output. And then they also will adjust the image based on sensor data. So we use the color and luminosity sensor. And what this does is the idea is that when the program is running, if an astronaut happens to float past the Astro Pi computers as it's running, then the background color will change in the image that's being displayed. So it'll be personalized for that moment and for that astronaut. Young people can save and submit their code. They don't need an account to do this. They are going to need something called a classroom code, which I'll talk about in a moment. But they can save and submit their code. And once they've done that, then it runs, it goes into testing. And then if it passes all of our testing and our guidelines, then it will run on the International Space Station. And as I said, they'll get a certificate distributed to their teachers who've signed up in June 2026. And on the right there, these are some of the pixel art images that we give as examples in our project guide. So I'll show you where you can find them in just a moment. So to run Mission Zero, there's 3 main things that I wanted to make you aware of today. The first thing is registration. So I'll show these links after the session as well. But the first thing is that all teachers taking part in Mission Zero, and ideally in Mission Zero on Thursday's live lesson, will need to register for Mission Zero before the session. When you register as a teacher, you will be given a unique classroom code to share with your students. And this is so that we can see, as a teacher, you will be able to see who has drafted programs and who has submitted programs. And most importantly, you will receive the certificates for all of your students in June for you to distribute. The reason that we do that is because it's much easier for you as their teacher to give them this to get the certificates into the hands of the right person than it is for us managing the program. And just to give you a sense of the participation, we had over 25,000 young people take part in Mission Zero last year. It was our highest ever year, and we're on a very good trajectory again this year. The next thing, the next bullet point is the Mission Zero project guide. So this is a Raspberry Pi Foundation step-by-step guide that young people will need to follow for the activity. And by the end of this guide, they will have a fully working program. It provides all of the code that they need, and they can add it to a coding environment or our starter project, and then they can modify it as they choose. All of the guides are free and accessible online and work on most browsers. And this is what the young people, if you're familiar with Raspberry Pi project guides, they will be reading through the guide as they do the activity and ticking off sections as they complete them. The starter project, the final bullet point on this slide, is the coding environment for the activity. So students, how they'll be working is they'll need to be copy and pasting code from the guide on one tab into the code editor on another tab. So they need two tabs open in their browser, or two windows. And as I said, they can modify their code as they choose. There's lots of different ways they can do this. In the guide itself, the project guide, we provide 7 pre-written coded examples, and they can use those and modify them. And I think that would be the best use of their time for the session on Thursday, and that's what we'll be taking them through step by step. In reality, they can create their own designs, but in order to do that, you will probably need to have perhaps more than one session. And we have a worksheet available online that you can print off as well, where they can design their own pixel art before they start coding. So that could be something you may be interested in doing either before Thursday or if you're running this at a different time. So those are the 3 main resources and points that I wanted to cover in terms of getting ready for the session. Number 1 is to register so that you receive your classroom code before the session, which you can give to students. The project guide, I would suggest that you get familiar with that as much as possible and work through it. I would say it takes about 25 minutes to half an hour if you've not done it before, and you have some familiarity with coding and with Python. You don't need to be an expert by any stretch of the imagination. I'm not a programmer by trade, and but of course I'm familiar with it, so I can get through it quite quickly. But it is, but do have a look if you have time. And then the starter project itself, I will show you that now and just show you how to navigate across the 2 different resources. Okay, so Brian, if there's any questions while I'm talking, I've got too many windows open, so so do just say if there's any questions or if anyone has.
I've just popped the link into the registration site in the chat for those teachers that are there. There's no questions so far.
Fantastic, thank you. So I'll give you the first link and just talk you through navigating between the 2 kind of resources for delivering the session itself. So the first one is the project guide. So that's rpf.io/mz guide. And this is where you'll find all of the instructions. So I'll just do a quick explainer here. The Astro Pi materials are all hosted, the project guides are all hosted on the Code Club project's website, which is another initiative by the Raspberry Pi Foundation. The first 2 pages of this guide are about what you will make and then about an Astro Pi computer. Thanks, Brian. So there's a certain amount of explaining here, which I will do most of on the call on Thursday. And I've already covered.
You want to share your screen, Fergus? Sorry, we can still see your slides. I think you're probably speaking about the website just now.
I am, yeah. Beg your pardon. Sorry.
It's okay.
Here we go. Can you see that? Okay.
Perfect. Thank you.
Lovely. Thank you for the prompt. So this is the project guide. This is where you'll find all the instructions for building your program. So we've got 5 steps on the top left there. And the first 2 I've already basically gone through. It's what you're going to make. There's a little demonstration of our Astro Pi simulator, which you'll see on the starter project, and just a few things about what you will need. Just going to move my window so I can click next. Then we've got what is an Astro Pi. Again, on Thursday, I'll go through what is an Astro Pi, and it's just a bit of kind of framing, what you're going to do, where's your program going to run, etc. Where we actually start the activity is display an image. And on this page, the first thing that you're asked to do is open the Mission Zero starter project. And to do that, you just click on this link here. And what you should arrive at is this page asking you whether you want to start, open an existing program or start a new one. So we're going to get everyone on Thursday to start a new program. And here we will find what's called the Astro Pi Mission Zero starter project. So this code editor is the Raspberry. In the background, you've got the Raspberry Pi code editor here, which is a free resource. This is an instance of it that's been set up to simulate the Astro Pi computers. And this is where we're going to be adding our code from the project guide to create our working program. So if I just quickly hop back to my project guide, we've got a bit of explainer here about the code that you can find when you open the starter project. So none of this needs changing. This is just importing the relevant libraries and a bit of setup to make sure that everything's going to work when we start adding our code. But the first thing we go through on this project guide after we've opened up our starter project, there's a bit about colors and how computers recognize color, and a couple of little demonstrations here of like RGB values and how they can be changed to produce different outputs. We've also got a list of variables here. So when I click on this, we've got a full list of alphabet characters and the colors that they're going to represent in our program. And then if you scroll down, you can see all of the characters, their RGB values, and commented out, you'll see the output description as a color. So this is all just explainer about how the program's working. These are the main concepts we're introducing here. It's about variables and how we're also using lists to create an image. So what that looks like in our program is this. The first thing we need to do, sorry, second thing we need to do after we've read that explainer stuff is choose our image. And here's where we find a preview. This is the fish. Then below that, this is our list of variables, their RGB values, the color name, and then this is how our image is written as a list to produce the right output. So what young people need to do is choose their image. We've got 7 to choose from here. I'm quickly just going to choose the fish and show you. I'm going to select all of this code. I'm going to click back to my my coding environment, and I'm going to paste that in under where it's commented here, add color variables and image. So if I get to this point, what lots of young people will do is they'll click run, and now you'll be disappointed that there's nothing showing on my Astro Pi, and it's just all the LEDs have gone black. This is the first hurdle after we've got through switching between tabs. So first hurdle, what do I need to do? I need to display my image. So if I hop back to my guide, the next tick box, so let me just reframe. I've chosen my fish, my image. What I need to do, and this is a good way for them to follow along, is to just tick this box. And that means I know where I am in the guide, and it helps the young people taking part just to follow exactly where they are. So the next thing to do is to tell the Astro Pi computer to show my image. And I do that by going to the commented line here and pasting in sense.set_pixels image. And when I click run now, you should see my fish. So this is where a lot of people will get to. They might want to start playing around, for example, with some of the RGB values at this point. But I think in the interest of time on Thursday, we're going to keep it, doing it step by step. I'm going to get everybody to add in the code for their chosen image, and then the next step will be display that image. And these are the two main steps on this part of the activity. So I'm going to click this here. If I just unclick these, you can see I've run my program. It's showing it on the LED matrix. I'm not getting any code errors, but there's a couple of prompts here for common ones that you might see. But at the moment, mine's working. And so I'm going to tick that box. Okay, so at this point, teams can save their program. And so if they want to do that now, they can do. It will take a bit of time on Thursday, so I will skip ahead at this point. But what you can see here is that this is where you would put your classroom code. It's going to be what you'll be given when you register as a mentor is 2 randomly generated 4-letter words. So let's say have lots is my classroom code, and my team name is going to be Fergus 1, 2, 3, 4. It has to be up to 8 characters long. So I'm going to leave the save and submit to the end of the session because it can take a little while people come up with their team names. If they want to come up with their team names in advance, it may save us a little bit of time. So we could do that if you have time to speak to your students before Thursday. If not, we'll do it on the day. But this is where you will need to put in your classroom code, and then the students will come up with their team name.
It could be an individual as well, couldn't it, Fergus? If you want to do it individually, yes. Yeah,
it can be an individual student, or it can be up to 4 individuals in a team. But for something like this, depending on the setup of your classroom, it works well as like a paired programming activity if you want to do it that way. Okay, so on the screen you can see here that I've got a little checklist as well for submitting my code. So it runs free of errors so far, which is great. It doesn't use the color and luminosity sensor yet, but it does use the LEDs. So I'm 2/3 of the way through getting a working program. So as I said, I'm not going to save in progress at this point in the activity. I'm going to skip to the next bit, which is to censor color. So this is where things start to get a little bit more complicated. We've got our image. We've told it to display on the LEDs. Now what we're going to do, and this is what is explained here, is we are going to replace the RGB values that we've given to the variable C with RGB values that we are capturing from the simulation of the color sensor in the Astro Pi. So the next thing that I'm going to do in the activity is I'm going to copy and paste these 2 lines of code.
Sorry, Fergus, I think you're on a different screen again from what we can see.
I beg your pardon. Sorry, I think I'm sharing tabs and I keep having to switch between them. I beg your pardon. Let me stop sharing for a moment and see if I can reshare the whole window. That might be a bit easier. There we go. Okay, can you see that okay?
Yes, perfect. Thank you.
Brilliant. Thank you. Apologies for that. Okay, so I'm going to select these 2 lines of code, copy them, and hopefully it's switched over to my code editor.
Yep.
Brilliant. Thank you. And I'm going to add these after my list of variables. I'm going to paste in these 2 lines of code, which is saying RGB is going to be the RGB is replacing what's written here, basically. So the data that I'm getting from my color and luminosity sensor is going to replace these RGB values in this way. Okay, so now when I click run, what should happen is you would see this pink color down here as replacing whatever the variable C is. So I should get a fish with a pink eye when I click run. Let's see if that works. Okay, excellent. So that's working now. And if I go down to my checklist, my program's now running free of errors. It's using the color and luminosity sensor, and it's using the LEDs. So I have a working program now at this point that's eligible, and so I can submit it. I think on Thursday, because we're going to be broadcasting to potentially hundreds of young people, this is the point at which I will hope to get everybody to, and we'll have to do it in quite a kind of slow and structured way, where I'm saying, okay, we're going to add your code and give it a few minutes for people to add each section. But there is more to the guide if you want to have a look at it, and if we do get further, then then that is great news. But the next steps of this are to turn your program into a program that runs within 30 seconds. And in order to do that, you need to create a for loop, which is going to run 28 times. So this is where it starts to get a bit more complicated, and that's why I'm recommending that we just try and get everybody to the point where they have a working program that's displaying, rather than going into making it a 30-second program. But I will just demonstrate it to you now quickly. What I would need to do to create my for loop is I'm going to add a line of code which is above where I'm taking my color sensor reading, and I'm going to tell it to run 28 times. Up here, this is the number of times I want to run it, and each time it runs, I want it to pause at the end of these lines of code for 1 second. And in order for the computer to recognize that this is a loop, I need to indent it. So to do that, I select all of these lines from number 20 down to 35 and just press the tab button. So now when I run it, it should repeat this program for 30 seconds or for 28 seconds. And we'll see it running down here on my timer as well. But what this enables you to do is to change the color that is being simulated when you're running your program. Now you won't be able to see me change the color. For some reason it doesn't appear. When I click on the color box, I can see a color picker, so you will have to do this yourself to see it, because it doesn't seem to preview when doing it as a presentation on a screen share, but I'll show you what the result is anyway. So when I click on this, I should be able to see my program starting to run. Okay, it's displaying the image. I can see the timer ticking away. But also now, when I click on my color picker, which again you can't see, and change the color, you should see the eye color change in my fish. And that I'll be able to do that as many times as I like within 28 seconds. And now my program has completed. So that's the full kind of program. there's a couple of wrap-up things that we can do as well. Very quickly, I've done these steps. I've added my for loop. I've indented my lines of code. I've added a sleep command. And now what I can do, if I want to just tidy up my program, is I can clear the screen. It's not indented. So when I've run this for, let's just make it quite a short program. So when it's going to run now, it's going to show my fish, and then the LEDs are going to clear. Okay. And if I want to add more, then there's one final line where I can say, give a new color variable, and I choose the color. This is going to be variable X. I'll choose what RGB values it's going to have. In this case, it's a red color. And then instead of just clearing the LED screen, it will clear the image that's been called in this loop, and then it will show whatever color X is defined as. So if I run it quickly now, it will show my fish, and it will clear to it should clear to that red thing. So clearly I've got a slight bug there that I need to fix. There we go, 2 loose ends clears. Now if I run it, it should go red. There we go. So that is the full program. And just to kind of recap the steps that we're going to go through, they are the live lesson structure is that I'm going to introduce Astro Pi and Mission Zero, what we're going to do. So that's the first 2 steps in the project guide. Then we'll all code along together to add the colors and an image, then display the image. Then we'll use the color sensor. If we have time, we will then start to create a for loop and close the program. But steps 4 and 5 are going to be dependent on how quickly we're getting through the live lesson itself. And then the final step, which we will definitely try and do, and which we need to allow a bit of time for at the end, is to submit the programs. So that's when they'll need your classroom code, easily accessible, and there are a few details that each student needs to input as well. And those include first name, gender, and age. We only ask for first name because we don't need the second name or any other details, but on their certificates, it will say their first name and the school or organization from which you are running the activity. And that's pulled from the registration information that you as a teacher or mentor provide. So does anybody have any questions? I'll stop sharing my screen now.
So I would say, Fergus, for those of you who've done coding before with your pupils, perhaps you've done some Scratch coding, this is the next step in moving from like a block-based programming environment to a text-based language. And with the copying and pasting of code, it does restrict the possibility of making lots of kind of syntax errors. That's because you're not ask people to type things in, but it does allow you to really see how real programmers write code, and when they write code for the space station or your washing machine or your car or the app that you use. It's a really exciting thing to have the code running in space, and you might even see some parallels between some of the phrases and things you've seen in things like Scratch and what you do here. So for example, that for I to equal 1 in 28, that's the repeat loop in Scratch, that repeat 28 times. And now it's got that C shape. When we indent in Python, again, it's knocking it in, it's indenting it, so it's all contained within it. So there are real parallels between block-based languages and this syntax-based language that we have here. Really obviously that you could choose one of the pictures, copy and paste it, add in a few extra lines of code and hit submit. But if you are feeling creative, you could download the template and start thinking about the colors you want, and you can see in that little grid, that little array, all the A's, B's, C's, D's. Think about the colors. It's a bit like paint by numbers, but with code. So you can prepare for that beforehand, or indeed you could come to the lesson, do this with Fergus, and then perhaps run it yourself later on to give the pupils a bit more time to come up with their own designs and implement it. So lots of opportunities here. I'm going to send, Fergus, if it's okay, a copy of your presentation to everyone who's registered, as well as a copy of this video, just to make sure that folk are registered before they join the class. Otherwise, it might get a bit chaotic towards the end there.
Yeah, that's absolutely fine. And the slides that I've prepared for today are, as I might have accidentally skipped onto, there's the slides that I'm also going to be using on the day as well. But once I've kind of set it up and introduced the activity, we'll be going over to kind of a live code along where I'll be demonstrating it as I did today. But
this is a bit more for me, I suppose, than anyone else. But see, if we do have teachers in classes that join at last minute and they haven't signed up, can they still do the coding activity but just not submit it, and they could read it again later on? So can you access the credit? Right. Okay. That's all I wanted to do. So again, because I do know that teachers are busy and they might join and realise they've not signed up. So they might be able to come through and do the activity, but they won't be able to submit it to the space station. They'll have to then go back and maybe do it again later on in the week or whatever.
Yeah, and the activity is running until the 23rd of March, 2026. So there's plenty of time for them to do that. Registration is very quick as well. It's just a few bits of information about, themselves, contact information, and venue details, so like the name of the school or organisation that you're running the session, and the postcode as well. And the reason we ask for that is because we want to be able to see where people are taking part from, what kinds of organisations and things like that. But the form itself is quite quick. So I think what I'll do is prompt anyone joining to register at the beginning as well.
Yes, just in case. Yeah.
Because it doesn't take long, but by the end of the session, they'll need that classroom code as well if they want to submit it.
So, thank you for for joining us this evening, Fergus. And does anyone in any teachers out there have any questions for Fergus? Or are we happy to kind of crack on? You can just type your question in the chat if you so like. I'm going to take that as an overwhelming no. I can't see an indication of anyone typing. Well, there we go. No questions, but looks exciting. Thank you, Mrs. Jan. I hope I'm saying that right, Jan.
Thank you.
That's right. That's great. Okay, folks, as I say, I'll pass on the slides from Fergus via the email that you registered for the live lesson with. Just so everyone has it, and I'll get any links that you might need on the day. Previously, when we've had live lessons that have links that we want pupils to use, like sample code, we do send those links in advance. So again, via your Google Classroom or your Microsoft Teams or whatever, you can share them in advance with your pupils. Just saves that wee bit of time and saves lots of people making mistakes when they type things in and the like. But other than that, I think we're good to go.
Wonderful. Brilliant. Well, thanks very much for having me, Brian. And really looking forward to Thursday and to seeing everyone online then.
That's great.
Wonderful.
Okay, Fergus, if you